Welcome to Mathematics with Tom. I am Tom, and today I'm going to show you an example of something that's not a vector space. In our previous example, we looked at the set S, where we said that S was the vector x, and it was defined as the vector that where the first component was twice the second component. And we said that the A could be any real number. So let's try this. Let's take a look now. Let's take a look at, I'm going to call this S prime because I'm going to just make one little tiny modification. Let's write this as the vector x is equal to, I'm going to write it a little bit different. How about we'll write it as A, and we'll use a column vector of 2, 1, plus the vector 0, 1, such that, again, that A can be any real number. Now, I'd like to show you why this is not a subspace and how it fails, and this one fails brilliantly. Well, remember, we have three categories that we need to take a look at. So, number one is we have to show that the zero vector is in S prime. Well, notice this. Well, I'm not even sure where to start thinking. So let's try this. Let's take a look at a picture. I like pictures. This is a good way to start when you're just not sure what else to do. So let's give it some tick marks here. How about 1, 2, 3, 4, 5. I'm not sure. We might need a bunch here. 1, 2, 3, 4. Let's go the other way as well. 1, 2, 3, 4, 5, and 1, 2, 3, 4. Now let's graph this a little bit. For example, if A is 0, and I'm going to do a little bit of scratch work, and just so that we can see that scratch work, I'll write it down here. So if I have x when A is 0 times 2, 1 plus 0, 1, well, that's going to be the vector of 0, 1. So I'm going to put a point there. So that's going to be the point right there. And then let's try the next one. How about when the vector x when at 1? So 1 times 2, 1 plus 0, 1. Well, that's going to be the vector of 2 plus 0 and 1 plus 1. That's 2, 2. So let's make another graph here at 2, 2. Well, take a look at that. What does it do? It shows us that first vector, 2, 1, 2, 1, is working as essentially the slope of the line, taking it over 2 and up 1. Now, just in case you're wondering, my foot got caught in the wires. All right, now we can continue. So, what do we get? We have then, I think we could make our line. So if I started at the vector 1, 0, I could go down 1 and then left 2. And so here's the line. You can see the line forming. It's just this one right here. And it's this one that just continues out there as well. So that's our line. Now, let's try the first one. Well, the first one looks like we have a problem. Because the 0 vector, we said, well, that's just right there. Well, that vector, that subspace, does not have the 0 vector in it, no matter what we do. Because of that, we've failed already. So to answer question number 1, we can say 0, the 0 vector is not in S prime. So we already have it failing once. And if this was a proof or a test, you could say because of that, it can't be a subspace. But let's just see how in other ways that it can fail. And the other two were the closure requirements. So the second one says that if we take any two vectors, let's take the vector x, and we take the vector y, then that result needs to still be in that subspace. So we can do this generally, or we could do this by example. Well, we actually have we actually have two specific vectors. So let's just try. I'm going to call this vector down here. We'll use that as our x, and this is as our y. So let's try that. So if I take x plus y, well, x is 0, 1. And y is the vector 2, 2. And we add that, we get the vector 2, 3. Okay, well, let's see where the vector 2, 3 is. If I was to graph the vector 2, 3, that would go over 2, then up 3. Well, that would take me over 2, up 3. That would take me right there. That's the vector 2, 3. So look at this. So now, not only was the 0 vector not in S prime, but the vector of x plus y just jumped right off the line. It jumped out of the subspace itself. So let's see. Wow, okay. So wonder if this line can go 3 for 3 failures. Let's try. 3 for 3 failures. So let's take any scalar c in the real numbers, and let's just multiply it. Multiply it by any vector that's in S prime. So we're going to take, c times, we could use the general variation. Or we could just use one of our vectors to help you see this. Let's do this one in the general. So c times x, okay? Well, remember now, c times x. Well, x is the vector of a times 2, 1 plus 0, 1. Okay, well, that is going to give me AC times 2, 1 plus what? Plus 0 times c. Well, that's where it fails, right there. Why is that? Because look at this vector right here, 0 times c. What that's going to do is, if c is a positive number, I'm going to c is a positive. Let's do this in this nice light green. If c is a positive number, it's going to take the y-intercept and just start moving it up the y-axis. And if c is a negative value, it's going to move this y-intercept down the y-axis. In other words, we're going to land somewhere off of the orange line. And so we can say with the utmost confidence, so S prime is not a subspace. Sub is not a subspace, okay? And that would be an example of why they fail. And what I really wanted to also emphasize is this. Number 2 and number 3, these are the closure properties. And what's so important is when we say it's closed, it means it stays within itself, within the set. But this one failed both closure properties by when you took pieces from itself and you put them together, they ended in another place. They ended in another place, and so closure failed. So that's an example of what would happen when it's something, a space is not a vector space. All right, thanks for watching. We're going to look at a couple more examples in the next video. See you there.